Okay, so we've talked about growth and decay model, which is basically one and the same. What happens with interest? This is sort of an interesting one. We have this model that says interest, and it says essentially this. We know how simple interest works. Simple interest says take the amount of it to get the amount of interest that you earn, take the principal that you invest, multiply it by an annual percentage rate, and multiply that by the amount of time in years that you invested. So that gives you the amount of interest. That is the amount of money that you're actually paid for keeping your money in that bank, or with the other way around, you're paying them for a loan, let's say. So what do we do? Well, we want to be able to calculate an account balance. Now, if we were just doing it with simple interest, the way it would work is that the account balance would be equal to the principal plus the interest, right? You can think of it as interest, principal plus interest gives you the account balance at the end of the year. If you have $100 that you invest at 3%, that means at the end of the year you'll have $103 in that bank account. All right. Well, if I rewrite that, here it is. I get the account balance is equal to the principal plus the principal times rate times time. Now, you have these other things below it. Let me just develop this a little bit, because this will be really, really interesting. Um, how do I actually work this out? Well, you know how it works. Let's say if I were just doing simple interest at the end of each year, right? So at the end of each year, I take that 3% interest, I put in $100, I get out $103. If I don't take out that $3, the next year, the amount of money that's earned is 3% of that $103. So what does that mean? Well, let's assume that for the purposes of calculating compound simple interest, what we call compounding, we let t equal 1 year in our simple interest formula, which means that our account balance would be equal to the principal plus the principal times the rate times 1. Now, algebraically, I can factor out the principal, and that's 1 plus the rate, right? So if you think about that 3% interest for $100, right? If I put in $100 at 3% annual interest, right, my account balance would be equal to that $100 times 1 plus 0.03, right? We put that in decimal form all the time. That's 100 times 1.03. And so we'd say our account balance at the end of that 1 year, if we just earned simple interest at the end of the year, would be $103. Okay, how do I use that? Well, what would happen at the end of the second year? Well, if I wanted to do it for a second year, right, this is year one, if I want to just let that $103 ride, that means for year two, my account balance is going to be $103 times 1 plus 0.03, right? Which is to say, uh, well, really, I could have gone back and said 100 times 1.03. Let's let me just try and keep it simple right here. It's $103 times 1.03 again, and we're just multiplying by 1.03 each time we do this. So if we take 103 times 1.03, we get 106.09, right? So in this next year, we would have a total of $106.09, and then we would roll that over again for year three. This is year two, right? So we would just keep on doing this and get the next amount for year three, right? Let that roll over. Well, it seems kind of a pain to have to do this year in, year out, and there's no self-respecting banker that's ever going to do this. So let's examine what happened. This first year right here, we took 100 times 1.03, but then we multiplied by 1.03 again. If I wanted to get it at year two, why couldn't I have just said, all right, take that amount of money that I took initially, $100, times 1.03, which is what I would get at the end of the year, and then multiply that by 1.03 again for my second year. Right? You get 106.09. At the end of year 3, I would have 100 times 1.03 times 1.03 times 1.03. Well, wait a minute, that's kind of a waste to have to keep writing 1.03 again, right? Aren't we really saying $100 times 1.03 to the third power to get it for the end of year 3? Well, that's exactly what happens right here. If we keep on letting this amount of money roll over as our principal in each succeeding year, we get what's called compounding interest. And simple compounding interest says, all right, if we just earn interest at the end of each year, then after t years, our amount of principal will be 1 plus whatever the rate is raised to that t power. Right? So if I wanted to do this calculation, I wouldn't have to do this business over and over again. At the end of 5 years, right, I would say that, well, my account balance would have been $100 times 1.03 raised to the 5th power. Let's see what that would be right here. Let's take 1.03. Here, let's see, 1.03, raise that to the 5th power, and then multiply that amount by 100, and I end up with $115.93. $115.93. Always round to the nearest cent, by the way, with these dollar and cent problems, right? This is how much money I should have at the end of my first year, or at the end of 5 years with this amount, right? Okay, so this is simple interest right here. But as you know, interest doesn't really work that way. If you have a bank account, you know that bank accounts occur monthly. Some investments accrue interest quarterly, every four times a year. Some could accrue it daily, 365 times a year. How do we account for that? Well, what we do is this. We say our account balance is actually going to be equal to the principal times 1 plus, well, if we're accounting for that yearly interest rate and we divide it up 12 ways monthly, let's say, right, we would take the amount of money and divide it by 12, the interest rate, and divide it by 12, which you think, oh, bummer, right? Less interest. But remember, we're doing it 12 times each year, so that means we multiply the amount of time times t to up that amount. So if I'm interested right here, I could say, well, whatever the number of compoundings, the number of times that I divide up my interest per year, right? This is called 12 compoundings per year if we deal with monthly. Then we can say that any n compoundings is equal to the principal multiplied by 1 plus the annual interest rate divided by the number of compoundings per year raised to the number of compoundings per year times the amount of time t. So that's going to give us our model that we're going to use in our next couple of examples.